Question 2. Random variable, we're given that it is normally distributed. We're using the letter x. We don't know the mean, that's mu, but we do know the standard deviation, which is 5. We're also given this information that the probability that x is less than 23, a specific value of x, then we have the probability is 0.9192. A good idea, whenever you're doing any normal distribution question, is to sketch it. So we have the area underneath this particular value here, 23, the area below that, to the left of that, under the curve is 0.9192, and we have mu in the middle. So let's just explore this statement that we're given in the question. I've copied it out here. In order to make progress with a question when you don't know the mean or the standard deviation, you're going to need to go via the standardized normal distribution, which is the one for which we use z, and that has mean 0 and standard deviation 1. So we need to rewrite first this left-hand side of this equation here to turn it into z terms instead of x. So the probability that x is less than 23 is equal to the probability that z is less than 23 minus mu, mean, over the standard deviation, which we do know, which is 5. And we haven't done anything to both sides of the equation except rewrite the left side of the equation. I haven't multiplied or done any inverses yet. All I've done is rewrite the format, effectively, of the left-hand side of the equation. Now, we can use our inverse normal feature on the ClassWiz calculator to work out the value of this, because effectively we're redrawing our normal curve, but this is in terms of z now instead of x, and we know still that there's some value here, question mark, below which the area is 0.9192. But our ClassWiz calculator will tell us what this question mark value is, and that therefore allows us, because that question mark will effectively be equal to this expression here, it allows us to solve to find mu. So on the ClassWiz, go into the distribution mode and then inverse normal, and it will ask you for a few pieces of information. We need the area. That is the probability, so 0.9192. It also wants sigma. Now be careful here, this is for this standardized normal distribution, z wants to be, so sigma is 1, and mu is 0. If you'd made a mistake, as many do, and written 5 for your sigma, you'd have got stuck when you got to this point anyway, because we don't know mu, so hopefully that would remind you that we need the 1 and the 0 there. With that information, we can extract that the calculator comes up with 1.3997. So we can now write that this expression here is equal to 1.3997. I'd generally opt for 4 decimal places in pretty much all of your calculations whenever you're doing probability for any values that you're using as a maximum. If you're ever unsure, 3 sig fig is good for final answers, but for figures used in calculations, I normally use a little bit more than that. So we have this equation. All we need to do now is solve it, multiply both sides by 5. And then we can easily work out what mu is, and I get that it's 16.0 to 3 decimal places. And that's our answer to question A. Then we need, so question B is straightforward with the ClassWiz. It used to be a bit harder in the old days, but this is now quite easy, because since we know our answer to part A, we can just straight away reach for the class whiz and work this out. I've not left myself much space on the screen. Let's draw a little line here. Part B, and we're just again going into the class whiz, but this time we don't want the inverse normal, we want option 2 in that menu, which is normal CD. Lower bound is our answer from the last question, so I'm just going to put 16. Upper 23. Oops, 23. And we also need sigma and mu. Sigma, we're dealing with x now, aren't we? So that'll be 5. And mu, of course, is 16. What have we got? We get 0.4192. But we could have done that without using the class whiz at all. Notice that the question says write down. That usually means you don't need to do any more calculation except for something maybe really easy. Now let's look back at our diagram here. The probability that x is trapped between mu and 23, well, let's just shade that in. It's this bit here. Well, the bit to the left, which I'm going to shade green, this bit here, of course, is exactly half of the bell curve, so that's 0.5. And therefore, the red bit must be 0.4192.